Good morning everyone. So today we are going to discuss about the forced harmonic oscillator. So forced in the previous chapters we have discussed simple harmonic oscillator and then the damped or harmonic oscillator. So and this is the third one. So how they differ from each other? In simple harmonic oscillator, the particles move to and fro about their mean position. For example, pendulum keeps on swinging. It will keep on swinging until unless some external force is applied on it. But practically we have seen that swing and that pendulum gets stops after some time because some air friction comes into play. So due to that the simple harmonic oscillator becomes a damped oscillator practically. So damped one means where the oscillation ceases after a certain period of time due to some external factors. Now third is the forced one. Now forced oscillator is that which the oscillator which starts losing its energy. We want to provide the energy from the external source so that it continuously starts moving around the mean position, and that is called as a damped oscillator. Sorry, forced oscillator. So forced examples or best examples of forced or harmonic oscillator is that, for example, a child is swinging a swing. So when he or she is swinging the swing, so what happens when at one time she get a push or pull by herself. After that, the swing continuously goes on decreasing, but she want to enjoy the ride continuously. So he or she may ask anyone to continuously push her up. So when anyone from outside push him or her up so that he or she can continuously singing for longer duration, so that is called as a force. So the oscillation by a external source, that is called as a forced oscillation. So this forced oscillation is playing a very important role in our electronics. So let us discuss the mathematical part of the forced harmonic oscillator. So we have discussed in the previous chapter that the simple harmonic oscillator consists of these two factors, and then the damped harmonic oscillator consists of three factors. So this third factor was because of the friction. Now forced harmonic oscillator consists of fourth factor. Now fourth factor is that the force is going to be get added from the external source. So this equation is a complete equation for forced harmonic oscillator. We are going to solve this equation just like in the previous equations, and then we got the parameters or all different output from this one. Now we have seen this parameter divide both side by m, so it will be minus k by m into y minus a by m into dy by dt plus f by m. So that is the one particular part of the equation. So bring all this to the left side and this to the right side. So this will be plus sign and this will be negative sign will be this. Now we assume this to be omega naught square, a by 2m is to be y. So we will get a standard form of the equation. Now this equation we are going to solve it out. So where by solving the factor for y as well as for f. So let us say y is the solution of y is equal to f naught e raised to I omega t. It is a complex term. So and for solution of y is equal to a e raised to iota alpha t. Now we know that iota omega t can be written as cos omega t plus iota sin omega t. So we multiply it with, so it will be f naught cos omega t plus iota f naught sin omega t. Now or we can write f naught cos omega t. So that means that is the real part, because this equation consists of two parts, real and imaginary part. So f naught cos omega t can be written as real of f bar. So that means this part that is equal to real of f naught e raised to iota omega t. So that is equal to this part f naught cos theta. So that similarly we can solve the y also. Y is equal to real of a e raised to iota alpha t. So we did give them certain number 5 and 6. Now we put the value of 5 and 6 in equation A. So where we have to take the double derivative and the single derivative and y of y and then f. Then we are going to compare it out. So once you put this value, now we have find it out this one. So this equation at the first part y value of y is there, second part value of y is there, third part is y value is there, fourth is value of f is there. So when you take the double derivative, e raised to iota alpha, double derivative is alpha square minus alpha square, because iota square alpha square will be there. Similarly second for iota alpha will be there, and third for there is no factor, and fourth for f naught e there is no derivative, simple equation is there. Now this equation will be matchable if this identity holds good, that is equal to alpha is equal to omega. So if alpha is equal to omega, then these equations are equal. Now we can find it out the value of a. Up to here we have got this equation. So the value of a can be equated by f naught by m divided by this factor of minus of alpha square plus omega naught square plus 2 gamma eta alpha. Now we have seen that this condition was equal when alpha was equal to omega. Now we put the value for alpha is equal to omega here. So we will get f naught by m upon minus omega square plus omega naught square plus 2 gamma eta alpha. So that is the equation. So that is f naught by m. So we will get it here as omega naught square minus omega square plus 2 gamma eta alpha. So that is the equation of this one. Now what we can do is we can solve it by multiplying and rationalizing it out, multiplying and dividing by this vector, this minus this to upside, this minus this to lower side. So it will be a plus b into a minus b. So the equation will become f naught by m omega naught square minus omega square minus 2 gamma eta omega upon whole square. Since eta square is there, that is equal to this value comes out to be there. So minus sign will be there. So eta square is minus will be plus. So let us write this equation as a naught e raised to minus eta phi. This thing we have written as equal to this one because we want to compare it with the certain parameters. So that means e raised to eta phi can be written as cos phi minus eta sin phi. So that a naught cos phi is equal to the first part, real part, and a naught sin phi is equal to the second part. So that means a naught cot phi is equal to first part and a naught sin phi is equal to second part. That is the these two equations. Up to here we have got it out. Now to get the value of a and phi, what we can do to get the value of a, squaring and add both sides. So left side will be equal to a naught square, and when you add this square, so it will be equal to f naught by m whole square into omega naught square minus omega square whole square plus 4 gamma square omega square eta square, that is equal to minus, but the rest of the factor is same. So then we are going to solve this factor. So that factor come out to be this one, f naught by m into 1 upon this one and this one, and when you divide that, so you will get the this value 2 gamma omega naught square minus omega square. So that means we can get the value of y is equal to a naught e raised to eta omega t minus phi, that is a naught cos of omega t minus phi. Now f naught by m, now this factor we defined some other parameter. Now this factor we call this as a mechanical impedance, where Zm is called as mechanical impedance, which is equal to under root of 4 gamma square plus omega naught square by omega minus omega whole square, or we can write it as under root of a square by taking out the common factor k by omega minus m omega whole square. So that is called as mechanical impedance of the oscillator. The impedance of the, so that means impedance consists of two parts. One is called as k by m, another is called as a by m. Two parts, the one is called as a resistive part, other is called as a reactive part. So that means this impedance consists of this one and this one. This part is called as a resistive part, and other part is called as reactive part. So that is called as the reactive part. So that means this value, the resistive part arises from the damping force and causes losses of energy during oscillation. So this arises because of the resistance friction part, and the reactive part dependent upon the frequency of the applied force. It contains two terms. First term which is controlled by the mass, that is this one. One term is controlled by the mass, and second is controlled by the controlled by the elasticity of the spring or the restoring force. So when the frequency is very high, so when the frequency is very high, omega is very large. So 1 upon omega is very small, so this factor will be ignored. So Zm will be equal to m omega only. That is for large frequency. The mechanical impedance is equal to this one, m omega. Now for low frequency, what we can get is that is this value is omega is very small, so this value is very large. This value will be ignored, so that means Zm is equal to k by omega. So we have find out this impedance is minimum when omega is equal to omega naught, or k by m is equal to m omega. So Zm minimum is equal to a. So that is the reactive resistance which is going to be there. Now up to that we have find out the velocity. So we know that A is equal to this one. So dy by dt, that is the velocity which occurs due to frictional part, that is equal to minus a naught omega sine of omega t minus phi. So but we have find out that this a naught is equal to f naught by omega zm. So that value you can put it here. So that means velocity is equal to minus f naught by omega zm into omega sine of omega t minus phi. So this value will be there, this omega will be get cancelled. So that is minus f naught by zm into sine of omega t minus phi. So this value comes out to be there. Now that means this shows the velocity becomes maximum when the z element is minimum. That means impedance is minimum, velocity will become maximum. Similarly, we can also we had find out the factor of tan phi, that is equal to, that is the phase part, that is equal to omega square minus omega naught square. So when omega is equal to omega naught, what will happen? So it will be equal to 2 gamma m upon m omega minus k by omega, or we can write it as a upon xi m. So xi m. So that means when omega is equal to omega naught, this value put it here. So tan phi is equal to infinity, or that will be occur when phi is equal to 90 degree. So that means phase is equal to 90 degree, and v is equal to f naught cos omega t upon a. So that is equal to f bar upon a. So that means velocity will inversely proportional to the amplitude. So that is at the omega is equal to omega naught. Now we are going to understand the three different cases one by one, so that we will discuss in the next part.